Reflection is where light bounces off a shiny reflective surface. Refraction is where light bends when it moves from one medium to another. Light bounces in a particular way, and it bends in a particular way. Today we're going to investigate reflection and refraction, and try to find out how they work, using everyday objects. For this physics lab, you will need a mirror with no border or frame, or not much of one, a piece of paper, a pencil and ruler, a pin or thumbtack, this one's optional, an aquarium-sized tank of water, about 300 grams of salt, a laser pointer, a second large container of water such as a saucepan, a dark room, and a funnel. Experiment 1. Viewing reflection. Step 1. Take a piece of paper, fold it in half, and then use the ruler to draw a line along the fold. Step 2. Stand your mirror on top of the line. Make sure it's straight upright. You can use document clips or something else that is on hand to hold the mirror steady. Don't let the mirror move during the lab. Step 3. Draw a large cross on the paper, in front of the mirror but towards one side of the paper, meaning not right in the middle. You can then place a thumbtack or pin into the cross to make the experiment a little easier. Step 4. Turn up the lights and shine a laser pointer along the surface of the paper so that it hits the mirror and bounces. Adjust the angle until it hits the cross you drew. To make this easier, you can hold your right hand behind the cross. This way you don't have to run the laser along the paper surface. You can see the laser dot on your hand. Use the pencil and ruler to draw the path of the light, from the laser pointer all the way to the cross. Step 5. Repeat step 4 from a different position on the paper. Experiment 2. Reviewing refraction. Step 1. Fill the aquarium halfway with water. Separately, fill the other water container with water and 300 grams of salt. Mix the salt in until it dissolves. Step 2. Use the funnel to pour the salt water into the bottom of the aquarium. The funnel allows you to make sure the salt water enters near the bottom. Step 3. The salt water should form a layer near the bottom, with less dense fresher water on top. Step 4. Turn out the lights and shine the laser pointer through the aquarium at different angles. Step 5. Note down your observations. If you haven't already, now it's time to pause the video and get started. Good luck. In the first experiment, you investigated reflection. Based on the lines drawn on your paper, you should see clearly that light travels in straight lines. You should also notice that it bounces away from the mirror or reflects symmetrically. This is called the law of reflection, which says that the incident angle is equal to the reflected angle. These angles are measured from an imaginary line at 90 degrees to the surface or mirror, called the normal. In the second experiment, you investigated refraction. Pouring the salt water into the bottom of the tank, you created a density gradient. Lower down the water was densest, and then it became gradually less dense as you approached the top. This caused light to bend or refract in interesting ways. When light bends from a less dense medium, like air, into a more dense medium, like water, it bends towards the normal. However, in the case of the aquarium, the density of the material is changing more gradually, and this can lead to the light bending gradually too. Depending on how gradual the change, you may have seen light curve. As exciting as this is, light does still travel in straight lines in general. This is just an unusual occurrence caused by the gradual change in density. Reflection is where light bounces off shiny reflective surfaces. Refraction is where light bends when it moves from one medium into another. Light bounces in a particular way, and it bends in a particular way. Today we investigated how reflection and refraction work. Through observation, we noticed that light bounces symmetrically from mirrors. This is called the law of reflection, which says that the incident angle is equal to the reflected angle. We also saw that light bends when moving from one medium to another. This is refraction. Based on what we saw in the experiment, this bending must be based on density, because when density changed gradually, the light bends gradually, producing a curve.